Hi everyone. Okay, pause this if you like to have a go yourself, or otherwise continue watching it. See what you think. Okay, let's have a go. A particle is projected up a rough slope, inclined at angle theta to the horizontal. The coefficient of friction between the particle and the slope is mu. The acceleration on the way up is twice the acceleration as it travels down. Prove tan theta equals 3 mu. Okay, so first of all, let's draw a diagram. Here's the horizontal, and what happens is the particle is projected up. Okay, so the weight's bearing down. We don't know the weight, we just call it mg. This is perpendicular to the movement, this one, to our slope. So we can say down here we don't know the angle, so we're calling it theta. So this will be mg cos theta going downwards, and going along here down the slope will be mg sine theta. Okay, and that is contact force Rn, and it says it is rough, so we're going to have friction. We'll talk about friction in a second. Well, let's talk about friction now actually. So friction is mu times Rn, and in this case we got the mu, and Rn here is that, so friction is equal to mu times mg cos theta. Okay, so what we've been told, so when this goes up, let's have a look. So we know also Newton's third law, force equals mass times acceleration. Now as this particle is being projected upwards, the movement is going upwards, and what opposes movement is is friction. Okay, and this, so what we've got here is we're going to have what's opposing this, it's going to be mg, it's coming down, sine theta, so that's coming down in this place, and since that particle is going up, what's going against it is friction, so we've got to plus this friction, mu mg cos theta. So that's going to be our resultant force. So basically we got that plus the friction which is going against this, so that is equal to mass times acceleration. If we cancel all the m's, we get g sine theta plus mu g cos theta equals the acceleration. So that's the acceleration opposing this. Well, it's more of a deceleration, it's slowing it down, but we're going to compare it like we like. That's the what's going down this slope. So acceleration on the way up, so that's the acceleration on the way up, and that's going to be twice the acceleration down. So let's see, that's up. Let's look at down. Now when it comes down, it would have stopped and then start rolling down. So what happens here is as this particle has stopped and is coming down, it's got this slope which is coming down, mg sine theta, so it's coming down with that. However, when it's coming down, the motion of it's coming down, and what opposes motion is friction. So in this case, friction will be going against it, so the friction stays the same as the particle has not got any heavier, etc. So that stays as mu mg cos theta, and I'm going to call that, well, I'll call the acceleration gain, that's mass times acceleration, ma, and again we can cancel the m's out, and we got g sine theta plus that's called mu, no, sorry, not plus, it's a minus mu g cos theta, and that is equal to the acceleration. Okay, so we've got that. Now we know that the acceleration, so that's the acceleration that is coming down. Okay, and that is what's opposing it's negative, but if we're comparing it both coming down, we're negated that, so that's coming down, so that is going to be twice that. Okay, so I could have called that acceleration up, that's the acceleration down. Okay, so that is twice, so acceleration, the way up is twice the acceleration down. So I'm going to say, let's do this g, let's do this in red. So now we know that g sine theta plus u mu g cos theta is equal to twice this, it's double this coming down, so that's going to be 2g sine theta minus 2 mu g cos theta. So I'm going to take all my sines, we'll take this to the other side, and take that to the other side. So what I'll end up with getting is, I'm going to get 3 mu g cos theta equals, take that away from there, just g sine theta, 2g minus 1g sine theta, just g sine theta. I can actually cancel the g's out, so I'm left with sine theta equals 3 mu cos theta, and if I divide that through cos, I'll end up with tan theta equals 3 mu QED. That's required. Okay, it's all about looking at the motions, see how they're going. With this case, when that was projected upwards, the friction was added to the friction was added to the forces here, because it was going against the motion. Okay, so these were both negative going against the initial projection, whereas here, when it came to a stop, the particle and it's coming down, we only had that force coming down, okay, and the friction was opposing it. So in this case, friction was added on, in this case it was taken off, and then when you balanced it out, you notice that was the case. Okay.